This is a very much 2022 variant 42 question number 1. The first part can carry 2 marks. The point P in figure 1.1 represents a point mass. Then on figure 1.1, you have to draw lines to represent the gravitational field around P. To do this question, we need to know the following facts. We need to know how to represent a gravitational field by drawing gravitational lines of force. And you must also understand what is the meaning of a point mass. In order to answer this question, to get the 2 marks, the first mark is you must draw at least 4 straight radial lines to P. The reason why you must draw 4 lines is because the 4 lines must be equally spaced. You can see that the distance between the lines at a constant distance from P is the same. Then to get the second mark, we must add arrow to each line. And all the arrows are pointing along the lines towards P. The reason is because gravitational field always exert an attractive force. So that's why the arrow is always pointing towards P. P will attract any object with a mass placed nearby. Part B. The moon is in circular orbit around a planet. Explain why the path of the moon is circular. To answer this question, we need to know the conditions for an object to undergo uniform circular motion. For an object to undergo uniform circular motion, first there must be a force that provides the centripetal force. And the centripetal force must always be directed towards the center of the circular path. Or you can also say the centripetal force must be perpendicular to the direction of motion of the object. So in order to score the 2 marks in this question, the first mark is to explain who provides the centripetal force. The centripetal force needed for the circular motion is provided by the gravitational force of attraction, which has a constant magnitude. That's also important. Then to get the second mark, the centripetal gravitational force is always perpendicular to the direction of motion of the moon. There are 2 formulas for centripetal force. One is mv squared over r. One is mr omega squared. So you can equate gravitational force with gm_m1 over r squared equals to mv squared over r. Or you can equate gm_m1 over r squared equals to mr omega squared. Which formula you equate depends on which formula is given to, which variable is given to you. In part C, many moons are in circular orbit around a planet, about a planet. The angular velocity of the moon is omega when the orbit of the moon has a radius r about the planet. Figure 1.2 shows the variation of r cubed with 1 over omega squared for these moons. So the graph is drawn for r cubed against 1 over omega squared. So we equate gm equals over r squared equals to mr omega squared because the graph is drawn with r cubed against 1 over omega squared. So to answer this question, part 1, show that the mass m of the planet is given by the expression m equals to the gradient of the line divided by g, this line here. Where g is a gravitational constant. So if we equate m1 over r squared equals to m1 r omega squared. This is your gravitational force attraction. This is the centripetal force. You cancel off the m1. Therefore, you can simplify r cubed equals to gm times 1 over omega squared. Then you compare this equation to y equals mx. You will see that y equals to r cubed and your x equals 1 over omega squared. So the gradient of the line is equals to gm. The gradient for this line, AB, is your gm. So if the gradient is equals to gm. So m equals to the gradient divided by g, which is proven. To get the 2 marks, these are the 2 marks here. We will use the coordinate of A and B in the next page to get the gradient for AB. Use figure 1.2 and the expression in C part 1 to show that the mass m of the planet is 1 times 10 power 26 kg. We will find the gradient for the line of AB the coordinate is given again here for easy reference. So m equals to the gradient divided by g. The gradient for the line is 3.4 times 10 power 23 divided by 5 times 10 power 7. Then times 1 over g. G is 6.67 times 10 minus 11. This will give you 1.0 times 10 power 26 kg, which is shown. Then in part 3, determine the speed of the moon, of a moon in orbit around the planet with an orbital radius of 1.2 times 10 power 8 meter. We want to find the speed. So to find the v, and then you're given your r. So now we equate your gravitational force, which is gmm over r squared, equals to mv squared over r. We use mv squared r to represent the centripetal acceleration because the question asks you to determine the speed v, and the orbital radius is also given. So you can cancel off your m. So your gm over r is equals to v squared. Your r can also cancel off. So your v squared equals to 6.67 times 10 minus 11 times 1 times 10 power 26 obtained earlier, divided by the orbital radius. So this will give a v of 7,500 meters per second. This is how you get the 2 marks. This is how you get the 3 marks. The first mark is for the formula, then the v squared formula. After that, your answer is 1 mark. Then this is a summary of the facts that you must know to solve this question. You must know how to represent a gravitational field around a point mass. Number 2, you must know that the gravitational force provides the centripetal force needed for a massive object to orbit around a star or a planet. Then you equate the gravitational force, which is gmm over r squared, equals to mv squared over r, or gmm over r squared equals to mr omega squared, depending on the question and the data provided.